Was anyone here for Aaron's talk earlier? He talked about ADHD and dealing with too many threads in the wetware? No? Okay. So it was interesting for me personally because I do have some mental health issues. I usually say I'm mildly bipolar, but that's a little bit like being mildly pregnant. So I have manic phases when I go through these really creative phases and do all sorts of stupid things. And then I have a down phase where I reevaluate the ideas and find it. And actually what happens is, sometimes the ideas you have in the manic phase turn out actually to be still good when you're in a more normal mental state. So, tankrain, Karma Pi, rongo show. I entirely blame Monty Python's Flying Circus for the title and Python. At the end of this talk, you should know what tankrain is, what Karma Pi is, what rongo is, and hopefully had fun. So the talk's nominally about natural cats of all sorts, the wonders of the universe, the world of Python and Pi, gravity and lightness, moai and madness, the rongo way. Okay, that sounds good, or does it? So I'm going to actually run tankrain in a minute. It's a few years of Python code I wrote just to view images originally. I originally wrote it. The reason why it was called tankrain, we'll come to that later, actually. Karma Pi is a little, and again, don't worry about this gibberish here. Karma Pi is my own personal project that I started when I was doing it started actually, it's almost as old as PyCaribbean. The first PyCaribbean was 2 years ago, and I came here and gave a talk about hurricanes, and because I'm living in an area affected by hurricanes, I'd actually just been through two of the things, and I know people here have had a pretty tough year. Is there anyone from Puerto Rico made it here? No? Other islands that were hit by hurricanes last year? Yeah. So Karma Pi is my own little project. Originally started to sort of deal with CSV files, manage your data in the disk, and help you use tools like pandas, scikit-learn, matplotlib. But basically, organizing your data was part of the idea. But over time, it's really just evolved into the project where it's now about sort of 50 or 60 short Python code files, none of them more than about 500 lines, most only 200 lines, where I pursue an idea. As I say, I mostly end up with too much to think about before I do too much damage and write actual code. But there are lots of pieces that can be used to fit models to data and simulate futures and past as we know them. And that's my goal, is actually trying to build models so that communities can get a better handle on what climate change might mean for them on the sort of 5, 10, 15, 20, 30, 50-year time horizons. Let's see how this goes. So rongo, and you're going to say, is actually the name given to an ancient script written by the Rapa Nui people. Has anybody heard of it? Well, Rapa Nui or Easter Island? Does that familiar to anyone? Okay, you'll be familiar to that soon. So it's a script which is actually undeciphered. They don't really know what it means. I have my own theories on that, but we'll see. And Easter Island is the island with these giant stone statues stood up all around, all facing inland, apart from the ones that aren't. And I'll come back and say a lot more about that once I get to my main slide. So this is just the outline of the talk to give you an idea where we're going. So just going back, turns out we should all be singing Happy Birthday, Dear Python today. When Brandon Rhodes gave his talk 2 years ago, he pointed out that Python was actually 25 on the day of his talk, and I think it was around the 18th, this date. So we'll pretend it's Python's 27th birthday today. So it's getting pretty old. I mean, it's half my age, and I've been using Python now for about a third of my life. The other thing that Brandon Rose talked about during his keynote, it was a fantastic keynote, it was just after the LIGO experiment, and I can't remember what it's the Large something gravity observation. It's this massive experiment to detect gravitational waves. Is anyone familiar with that? Okay, I won't go into too much detail, but there's September 2014, I think it was, around then, the experiment discovered, it's a massive experiment that's been on for 30 years. They finally detected gravitational waves, and what this was a ripple in space-time generated by two black holes that collided with each other a billion light years away. And these black holes were both roughly 30 solar masses each, and by the time they'd coalesced into one black hole, the energy that they'd given off was equal to 3 solar masses of being turned into energy in a fraction of a second. Amazing experiment. The important point, well, the point where this is relevant to my talk today is that Einstein suggested that gravitational waves were a thing but didn't know it. 100 years later, we're in the wonderful position of knowing that they are a thing, and then we can now look at physics in a new light. So with that background, I'm going to try and fire up tankrain, and you'll have to... Oh, hang on. Bear with me, because the screen's not duplicated. So I have a little alias that basically runs a module of the project. That's what the Carmine is. So it's running the tankrain module. Most of our little modules actually have the if name equals main stuff, and they do something if you just run the module. So this tankrain basically expects to find a folder with here multi-day subfolders and a bunch of pictures in each of those subfolders. So it's actually quite good for giving a talk. Hopefully. Now, sorry. Okay, so we're up and running. So this is tankrain. I'm running it here. This is the print statements, which is my favorite way of debugging. So, how are we doing for time? Excellent. So one of the features of tankrain is it has a clock. If you press H, it's the world's simplest GUI, really. If you press H, it gives you a list of letters, and what this menu is the quick and dirty. I'll come back to that. We'll see more, but I basically, the way the GUI framework works, if you want a letter to cause an action, you just write a coroutine, so that's an async def whatever, and you bind the key to call that you set the thing up to run that coroutine when you type the key. So it means you've got all these asynchronous handlers, and to get the menu, I just interrogate use the doc strings from those. Sorry, that's better, isn't it? I use the doc strings from the coroutines themselves. As you see, I've got some typos. I don't advocate bulleting of atomics. Are there any atomic scientists here? Oh, okay, we're all right. It was meant to be the bulletin of atomic scientists. I won't go into that now, but basically, the bulletin of atomic scientists has this doomsday clock, which they set at so many minutes to midnight, which is their estimate of how close we are to destroying the planet. They've actually set it to 2.5 minutes to midnight about just over a year ago. I'm being optimistic, so I've doubled that to 5 minutes, which is great because this actually works as a great clock for lightning talks. So, what went wrong there? So if there are no photographs in a folder, oh, I know what I did. I used the wrong date, I hope. Sorry about that. If there are no photos in a photographs in a folder, you get just a rainbow. Oh dear, this is so difficult when you can't see your... Oh, here we are. I just need to get the focus in there. What date did I use? 2018, 139. Oh, I know what's up. There's no photos in the folder because we can't find it. Okay. Try again. Okay, now what I'm going to do is I'm going to make this full screen, and hopefully from now on, all we will need is the slides. Excellent. So we're going. So the reason why it was called tankrain originally, when I originally wrote this little bit of code, what I was really wanting to do I was living in Bermuda, and I wanted to download the Bermuda weather radar images so that I could browse them. Because the Bermuda weather, if you go to weather.bm, there's this wonderful site where they actually have rain radar, so you can know whether you're going to get hit by a thunderstorm on your way to work and delay leaving home or what have you. But you can only see the last 5 minutes, so I wrote this screen scraper to download the images, and then the same utility was used to view them, and now it's just evolved into a general image thing. This is actually an image from Hurricane Nicole over Bermuda. What fascinates me about this one, you can see some amazing patterns in here, and I thought at the time they were features of the radar, and some of the patterns in there are features of the radar, but they're also features of what happens when a wind field that's been going across the ocean hits a small island. Bermuda's a fascinating place, actually. It's like having a little stick pointing out, a pole pointing out of the ocean, and the storms come across and then they kind of splatter across it, and it breaks up storms, Bermuda. Some of the other islands in the Caribbean are like that too. The very shape of the Caribbean archipelago actually is kind of partly shaped by the storms. Yeah. Well, whenever a hurricane gets over land and mountains, they tend to lose their power. But I mean, Bermuda is really quite a little blip for the thing to be going over, and it has quite a significant effect on the storms. Anyway, so that's why it was called tankrain. Oh, sorry about that. We're running a bit fast. So Karma Pi, just to give you a little... there's also there's another part of Karma Pi. In the docs folder, there's a folder called No Dice. And that's where I just do random rantings on my thoughts on physics, which are really notes to myself, so that one day I can go back and try and write down what I was really trying to say. This is actually just about Karma Pi, so it's actually, the file's called redemption.rest, so I called it song. Going for a song, Karma for free, Mana 2, puzzles galore, and a vision. So if you like puzzles and word puzzles, Karma Pi is a good project to just browse the code and look at what I'm doing with code and see if you can figure out. And if you find something that interests you, great. If you find something that you don't understand, ask me a question. I'd be delighted to hear. It also is a project that really doesn't want to exist, so I'd rather work on downstream projects, and always when I'm doing something, I'm thinking, does this really belong in Matplotlib or Pandas or some other project? Because it almost always does, and also almost everything I've done, someone else has done before. So it uses Pandas for data. It doesn't actually use Jupyter, but once you've organized your data in this way, Jupyter would be very useful. And actually, that's another feature of Karma Pi. If you've got your own way of organizing your data and doing the same stuff, that's great. But what I really want to do is collaborate with you on the project of climate science and simulations. And so I want to remove barriers to that, and I don't want my own project to become a barrier to that. And I'm really of the philosophy that to really crack this climate problem, especially for small communities to understand their risk, we need a kind of distributed approach to the modeling and the sharing of the data. A centralized repository is potentially a problem, particularly for small... I mean, most of the weather data that I'm relying is coming from organizations from large countries like the USA, from NOAA, European Centre for Medium Range Weather. Smaller places don't really have the resources to store that, to manage that, well, to collect and manage that data, but they absolutely do need access to the data in order to understand their own world. So this is what happens. So I'll slow this down a bit. Okay. Random pictures of what happens when... So around a year ago, I was doing some consulting to a reinsurer, and that's sort of what I was using Karma Pi for. It was my open source project of building risk modeling systems. Long story short, last March, they had a reorganization in the company and decided to go in a different direction, and so me as a consultant was left with a summer and nothing to do in Bermuda. I was in a beautiful place, And I just started amusing myself. The manic phase crept in. This was an attempt to build the world's largest phone charger. And the idea was to get a trickle of water down, run a little turbine, it's actually an old a motor off a little drone, and I was going to take the wires from that and trickle charge a phone. I don't know whether it would have worked. I got it as far as here, and when this thing's cranking along, you can connect the wires to I actually had them connected to the microbit, and there was some current appreciable current being generated. What I discovered later is what I really needed to do was take a fan out of a PC and have a really strong current of water through, and then you will actually get something that you could charge your phone with. The other problem I run into was you need a steady flow of water, and so let me see if I can stop it at one of the slides that... Okay, so you need a steady flow of water to... This is where the water was coming out and driving the turbine at the time, so to speak. And so I put all these things on here, and actually this is one of the few times it rained, because the whole idea with this, it was going to rain and power the turbine. But of course, after I built it, it didn't rain for 2 months, which was a bit of a problem because there was no tank rain, so everybody in Bermuda was having to buy water. Nobody was happy. And I would sit here on the top of the hill watching these giant thunderclouds coming towards us, and they would just move to the left or the right, and we didn't get any rain. So a lot of madness here. Waterfalls. One of the things that this little collector here had, basically these hose pipes. It was actually quite pretty to watch. It was like a little water feature. I put stones in this bowl one time just for that, see what happened. You pour the water on them, and the stones sorted themselves into a spiral. I wish I had a photograph of that for you to see. And so it's amazing. What I really discovered by doing all this, I spent an awful time looking at water and looking at waves. And it's really incredible stuff, water. The other thing I did, I also spent a lot of time scooping water out of the pool to fill this thing up because it didn't rain. And it took me about 3 days to learn how to throw a bucket on a string into a pool of water and pull it out efficiently. I mean, I'm sure there's people in poorer parts of the world where they're having to get their water that way, and they would have been laughing at my early attempts, trust me. What else have we got here? Now, there's other madness going on here. I'll let it wake it up a bit. How are we doing for time as well? Okay, what time's lunch, past? Yeah. So the other little bit of madness, when I get to it, you'll see some pictures where... There you go. Oh. Let's let it go. There you go. You see these bottles? Don't do this at home. We had some friends come over, and they brought some bottles of Perrier water, fizzy Perrier water, and of course I put them in the tank at the top, which I'd fill with ice, and I was also for a while was pretending... One thing I was able to do with that whole setup was look at how once these systems of siphons and pipes start flowing, they empty very quickly. And we need to worry about that with the melting caps. So these friends came over, and I put the Perrier bottles in the ice, and then after they'd gone, I took one, and I'm sat in the pool, and I thought, well, I'll let the air out of it and let it sink to the bottom. So I did, and to my surprise, it stayed upright and walked off down to the bottom of the pool. I was like, oh, that's interesting. I tried to launch another one, and it kept falling over. And I was like, oh, that sucks. But then I got a few bottles, and I could launch 2 or 3, but the fourth one didn't seem to want to launch. And I came to all these theories that were mostly wrong about why I couldn't launch the bottle. It turned out the reason I couldn't launch the extra bottle was I hadn't got enough air in the top to keep it upright. So you need just enough air that not so much air that it floats, but just enough that it sinks, but enough to, the little bubble of the air keeps it in top. So, okay, some more madness, sitting around bottles. There's some, oh, not that one. The other thing I want you to notice here, let's see if I can, that's it. I mean, They're absolutely stunningly beautiful patterns that you get from light interacting with water. And what actually happens when these bottles are actually underwater. This one is just bouncing off this shelf. It's stunning to watch. And the bottles all wobble in harmony with each other. So, and what you see is actually the pool has got this kind of standing wave that's going like this, and the bottles are moving with it. And and the wave is sort of, has a direction, sort of, but waves are not really like that. And then the other thing that used to happen, so I'd put a load of bottles in, and then I'd go to bed, and I'd get up in the morning, and at least one had fallen over. It's like they had a fight in the night. And what was happening is, when the sun came up in the morning, it pours energy into the pool, and that wave gets a bit bigger, and they start falling over. So, why are we still, wrong, I pressed the wrong button. That's why we're going backwards in time. So, Rapa Nui. Let's pull these down a bit. Easter Island. That's a good picture of him. So this little man is lost. He's what's called a moai, and this is one of the statues from Easter Island. Sadly, it's found itself in the British Museum, although that was useful for me because I was able to get some pictures of a moai without actually going to Easter Island. One of the most interesting things about this character is I'd love to know what shape he is down below. This one is a very special moai. It was carved out of basalt. Most of them were carved out of volcanic tuft, which is a soft rock, easier to carve. And he was also at one of the most sacred sites on Easter Island called a rongo. Remember that rongo word? And the British, when they decided they quite liked him, so they brought him home to the British Museum. I mean, he's not the only thing in the British Museum that's traveled there. So this is Easter Island itself. Here's a rongo, and there's actually a magnetic stone here you can visit that's kind of got a really strong magnetic field, and that's where that moai came from. All these black things here are where there are platforms on which moai stood, and basically what happens is on the platform they carve off they carve the moai out of the rock mainly in this region. Initially, they have a rounded bottom to them. And then when they got in situ on the ahus, they carve off that bottom so they stand still. Now, I have some theories about this. Some archaeologists... So we asked, when the Europeans got to Easter Island and they saw these statues, the obvious question was, how did they get from the quarry to there? And do you know what the Rapa Nui people told us when we asked them? They said they walked on their own using manna. And, of course, we didn't believe them. So we'll come back to that in a bit. I find the distribution of these and the placing of the platforms fascinating. These little black dots here are individual moai, as opposed to, whereas the big black ones are big platforms, and these big platforms would have been ceremonial places. I wish I had a picture of them. Some of them have got 8 or 9 of these giant moai, about twice the size of the one I showed you. And they're intriguingly arranged in an order where there's a kind of sine wave that they're arranged in. Moving on. Rongo Rongo. This is Rongo Rongo. You see this character here? This is sort of like one of the sacred things in this people was the Birdman. Half man, half bird. You read Rongo Rongo by going like here, and then when you get to here, you have to kind of flip the tablet round because the characters are upside down, and then you read back along here, and now you flip it around and go like that, and so on. And then you meet in the middle, right? So, another interesting thing is, depending on how you count characters, A lot of the tablets have about 28 or 29 characters per line. There's a lot of repetition. You see things like this, you know, slowly changing things. So we asked the Rapa Nui, well, and apparently this is on a piece of ore, this tablet. I think it's in a Zagreb museum, this particular one. We asked them, so what does it mean? And they said, well, we'd love to tell you, but unfortunately, all the wise men who could read are now dead because you killed them or took them as slaves or whatever. So it's kind of unfortunate. But apparently these tablets, every home would have had one of these in. They were scattered all over the place. Now we're down to about 20 or 30 examples. So it's kind of intriguing. What are they? Oh, but what they did say is they're chants. Now this is kind of cool. And I want to do this with, it's too bad Rebecca Connolly's not like she's into dance. Anyone who's into dance, if you lay this down on the floor, and you get two of you, and you dance to a rhythm and try and make yourself look like the character, and then when you get to the end of the line, you swap places, and you do the same, you get a pretty good dance out of this. And you could also have it with 8 people. I really want to do this to see if it looks any good. Okay. So I'm in Bermuda. Around, my work had come to an end there. It was kind of becoming obvious we needed to come back to Canada. So it was time to come back to Canada. Pro tip, don't move from Bermuda to Canada in mid-December. It's basically the temperature gets multiplied by -1 and all this white stuff appears. Now, around this time, I'm on Twitter and I happen to follow this guy, Professor Ian Stewart, because back in the day for my sins, I went to Warwick University and studied mathematics. Professor Ian Stewart was a professor there. He's written a lot of really accessible books on Galois theory, Fermat's theory, and just general Does God Play Dice is one of his books. Is that right? No, it's Chaos Theory, and the subtitle is about God and dice. Now, he tweeted this, and I was like, oh, that's interesting. Colin Rote was my tutor at college. Now, I was an undergraduate. I probably spent a grand total of an hour and a half in his presence in his office in over 3 years, because I kind of didn't need to go to him too much, and I was quite intimidated by him, to be quite honest. But he's just written a book on cosmology, and I have a copy of the book here. I'd been going through this period of the summer also thinking about quantum mechanics and stuff like that, and so I was kind of fascinated by this. The timing was weird. So, meanwhile, so what I did, I put this book on my wife's Christmas book list and gave it to my 2 sons, and I was kind of hoping that they wouldn't realize that my social worker wife probably wasn't interested in a mathematical treatise on a new paradigm to the universe, but they'd buy me it anyway. Didn't happen, but by a happy coincidence, I moved back to Canada, and we were moving into a house, and we'd left a lot of stuff in Grandma's basement in Canada, so I retrieved a box of books, and amongst them was this Fred Hoyle, The Nature of the Universe. This was based on a lecture series that Fred Hoyle, a British astronomer, gave at Cambridge University, where he was a professor at the time, in around 1950, about the nature of the universe. And it's an absolutely delightful read. It's 125 pages, very easy to read, pretty much the opposite of this, actually. And he describes how the universe was formed, or his best theories on that. And at the end, he also talks about an expand. Fred Hoyle was probably one of the original exponents of the expanding universe. Did lots of stuff. He talks about how planets were formed, and his planet formation model talks about the mystery of apparently the sun should be spinning a lot faster than it is, and the reason it isn't is some of that angular momentum has been transferred to the planets. And Fred Hoyle proposed a mechanism whereby that angular momentum would be transferred to the planets, and he he basically talked about magnetic springs. So if you've got a magnetic vortex storm, if you've got basically, the sun's full of hydrogen atoms and ions, if you like, and there's lots of currents flowing in there, so you get a magnetic field. If you've got a changing magnetic field, you've got one in, the Earth's got an iron core, so it's a giant magnet, and Fred claimed that you could get these kind of spring things that would transfer momentum from one to the other. I might be getting his thing. And by the way, this is Pyrie, bless him. He was a Bermudian kitten, and he got abducted along with his elder brother, Snowy. And Snowy is 8 years old and had never seen snow. And at this point, he never wants to see it again. So, that's good. 10 minutes, yeah. So Colin wrote, this is his book. Now, the curious thing about it is, so basically, it's a complete new approach to understanding the universe. His original motivation was looking at spiral galaxies and asking the question, why do they always form as spirals? And the other thing that Colin is famous for is for not proving the Poincaré conjecture. Are there any mathematicians here? No? The Poincaré conjecture is one of these giant mathematical theorems that basically says the only interesting balls are balls that are embedded in three spheres, or two spheres. I always get confused about that. But basically, the balls that you know that are embedded in our regular space are the only ones that have the properties of balls, is what the Poincaré conjecture says. He claimed to have proved it in the late 90s. Unfortunately, someone found a hole in his proof, and then somebody else proved it, and Colin found the hole in their proof, and then a Russian guy, Perlman, I think it was, proved it, and he was the guy that didn't accept the $1 million prize. He was just interested in mathematics. So Colin's kind of a guy that isn't afraid to say, I think I've done something remarkable. The most remarkable thing about his theory is that he strongly does not believe in the Big Bang Theory. These spiral galaxies can sustain themselves for many orders of magnitude longer than the current estimate of the age of the universe. He also doesn't need dark matter in his theory, and given that nobody's actually found any dark matter, that's kind of, because in his theory, the dark matter is essentially all squished up and appears as a supermassive black hole in the middle of a galaxy. Now, you have to remember, in Fred Hoyle's time, another interesting thing about Fred Hoyle is he grew up in Bingley, which is the same town that I grew up, it's a little town that I grew up in North Yorkshire, or West Riding, I guess, for the first 8 years of my life, and that's why the book was at home. I think my dad knew that, and he was always buying books, and he'd bought this book, and one time when I was at my parents' house, I'd seen it, grabbed it, and took it home with me. And then it had ended up in the box in Grandma's basement until it was time to be read. It's absolutely fascinating comparing the state of cosmology in 1950 to currently. Fred Hoyle would not disagree with anything that Colin is saying, I believe, if he was talking today. There's nothing in his book. Fred Hoyle's expanding universe requires continuous creation of matter, which some people consider a little bit of a problem. Colin's doesn't so much. These spiral galaxies sort of continually recycle matter. And they get their energy from the black hole in the middle, which is supermassive, maybe 10 to the 8 solar masses. So we're talking about a massive black hole here. It's not quite clear, and part of his model assumes there's some inertial drag from the spinning of the black hole on the surrounding matter. I'm in correspondence with Colin, trying to figure out, because the book's pretty hard going. It's quite hard to actually tease out what assumptions he's actually making in his model and what he knows and what he doesn't. And the things I suspect whether things everybody knows or just plain wrong or whatever. So, new paradigm for the universe. As you see, this is me sort of trying to read it. And then, the usual reaction when you say to people, another thing about modeling the Earth and modeling the planets and the solar systems, it's a bit like modeling an onion. You've got layers, And really what we, let's slow it, let's stop this. One way of looking at space-time is these sort of different shells at a different distance from the black hole. It's quite, and largely you can, if you're far enough away from the onion, you can sort of treat it as a point in space and not worry too much about what's going on inside. I just want to get the idea of modeling a sphere, and maybe if this was Earth, if we could model the inside, on the Earth, modeling the climate, you really do need to know what's going on in the magma storms. And there's giant magnetic storms inside our Earth. I'm absolutely convinced of this. You've then got the oceans, which have got their own currents. That some of the ocean currents take 50 years to do one circuit. So, when the current, which is a little bit worrying on the global warming front, because it's going to take a while for everything to mix in that ocean. How are we doing for time again? Oh, I'm over. So I just want to say one more. I think there's one. So this is what happens when you tell somebody there's no Big Bang. And really the whole point of this talk is I believe there are a lot of things in life that and in the scientific world that we believe that may not be right. And it's those very things that are the barriers to progress. It's the same thing with the Moai. We're laughing at the Rapa Nui saying that these things walked on their own, but here's the thing. They're carved out of volcanic tuff. Volcanic tuff is magnetic. They take them out and they turn them through 90 degrees, and they make them in such a way that they wobble. A group of archaeologists are managed by tying ropes with just 15 people, just gently rocking from side to side, and a rope at the back to keep the thing stable. They can walk one of these things 150 feet in 20 minutes. So my question is whether the magnetic field, and there's a very strong magnetic field in Rapa Nui. If you go on YouTube, you can see videos of cars rolling uphill. That's how strong it is. The question is whether the magnetic field would be enough to act like the water did in the pool, so these things could just rock around. Now, there's another interesting theory about this, is that the Earth's magnetic field has not always been the same strength. At the time of the end of the last ice age, the Earth was cranking along, and apparently the magnetic field was stronger. I need to go and revisit that. So one of the things I want to do in KarmaPy is do a simulation to see how strong the magnetic field would be for these things to walk. And also to see, and then go and measure how strong the magnetic field is. So I think with that, I'll skip that one. That's a heavy falcon. Okay, this is worth a... This is really what KarmaPy is about. It's not talking... yeah, I know. Oh, I'm pressing the wrong button. That's why it's not working. Okay, it's going again. So this is the European Centre of Medium Range Weather Forecasting data on a grid. Now, bear in mind, what we've really got is one of those shells of the onion here. What I'm wanting to do, and I'm working away on the code, is to fit Markov models to these. You can get the Earth temperature on this grid for every day since 1979. You can also get precipitation, evaporation, all sorts of stuff. This is what you're looking at here is the anomaly relative to the mean over the last 40 years. And you can see the warming quite clearly that's going up on in the north. So with that, I think... Oh, I'm typing the wrong button again, going the wrong way. So with that, I'll leave you some cat pictures and more pictures. What I want to do as well is by fitting models to that, and also there'll be ways to actually use those models to run 10,000 hypothetical simulations in the future, and also spit out catastrophes by modeling the correlations with the states in my model. That's the plan. So anyway, yeah, these two cats, they've kind of bonded because it's Stockholm syndrome for cats. They're both stuck inside. They look at the door and then they see the snow and they're back in. So with that, I'll let everybody get to lunch. Oh, there's a prize for anyone who can tell me what the dark pictures are in this one. If I stop it on it. Where is it? It's gone. It's not there. Sorry, wrong one. Maybe it's this one. Yeah. I'll leave it on that. So thank you very much for your time. This is Ottawa's ice sculptures in their winter festival. Water is amazing stuff. Thank you very much.